India's borders have long been defined by its continental footprint, but the contest for global influence unfolds far from shore, out in the deep oceans. Right now, both China and the United States are aggressively expanding their naval footprints across the Indo-Pacific, racing to secure vital sea lanes. To maintain its position in this environment, India cannot rely solely on defending its coastlines. It requires a permanent, commanding presence in blue water territory. The Indian Navy fields two major heavyweights, the INS Vikrant and Vikramaditya. Their core design features a prominent upward curve at the bow. This curve defines the stow-bar system. Because of the short runway, fighter jets must rely on this physical ski jump to get airborne. As this comparison shows, to successfully clear that ramp, aircraft have to shed weight. That means taking off with a fraction of their maximum fuel and a significantly reduced weapons payload, restricting how far they can fly and how much firepower they can carry. While stow-bar carriers are effective for coastal defense, their payload limits and frequent refueling needs prevent them from maintaining a persistent offensive presence in the open ocean. The proposed solution to this range problem is a 65,000 to 70,000 ton supercarrier known as INS Vishal. It stands as the most ambitious defense manufacturing project in India's history. Instead of a curved ramp, INS Vishal features a completely flat deck. It abandons the stow-bar method for the chokepoint system, a catapult-assisted takeoff technology. This is the exact same launch mechanism utilized by the United States Navy on their Gerald R. Ford-class supercarriers, and it is the same technology that China is currently implementing on its newest carrier, the Fujian. This diagram illustrates the advantage. A mechanical catapult locks onto the landing gear and physically slingshots the aircraft down the runway. With the catapult supplying the kinetic energy, jets no longer need to shed weight to get airborne. Practically, this means the Vishal will be able to launch heavily armed fighter jets, long-range surveillance planes, and mid-air refueling tankers that could never clear a traditional ski jump. The carrier is also designed to integrate future warfare elements, specifically deploying AI-driven Ghost Fleet stealth drones capable of flying continuous 36-hour surveillance missions. By throwing heavier aircraft and persistent drone fleets further out to sea, the chokepoint system multiplies the strike range and surveillance radius of the entire Indian Navy. Launching heavier aircraft and sustaining a network of high-tech drones demands an immense amount of energy, leading to the Vishal's most critical engineering feature, its power source. The carrier is planned to run on a massive 500 to 550 megawatt nuclear reactor developed entirely by India's Bhabha Atomic Research Center. This map highlights the difference. Standard warships frequently abandon patrol routes to return to port for diesel. A nuclear-powered carrier generates its own energy, holding its position in the deep ocean for months without needing to refuel. This shift in propulsion removes the tether to coastal supply lines, transforming the INS Vishal from a visiting warship into a permanent, floating military base. That uninterrupted deep-sea endurance allows India to project power directly over the Indo-Pacific's most highly contested geographical chokepoints. No waterway is more vital than the Malacca Strait, a narrow channel where massive volumes of global trade and energy supplies transit. Positioning a nuclear supercarrier here creates a permanent pressure point, placing primary maritime supply routes within India's strike range. Beyond its role as a weapon, the Vishal functions as a central node for Indian industry, consolidating specialized domestic expertise into a single, high-end manufacturing pipeline. This visualization shows the depth of the collaboration. To build a ship this advanced, domestic electronics firms like BEL are working directly with private engineering firms to develop the complex AI and electrical propulsion networks required for the vessel. By keeping the supply chain within its own borders, the country moves away from purchasing foreign military technology and instead builds the infrastructure required to sustain its own defense needs locally. By combining nuclear endurance with heavy catapult-launched strike groups, the Indian Navy moves from securing its own coastline to actively resetting the Indo-Pacific power balance.